Welcome to Chapter 12, Chemistry. Okay, so a few of our learning objectives. We are going to list the differences and know the difference between organic and inorganic chemistry. You're going to categorize, give examples of different substances. You're going to also, in your own words, describe oxidation reduction and the reactions that it causes. You're going to be able to define differences between pure substances, physical mixtures. You're going to evaluate some of the difference among solutions. Also, you're going to be able to explain what pH is and how it affects and pH scale works, how it all works.
It's a lot of stuff that
There's a lot of stuff.
A lot of stuff we're going to talk about.
So,
all right, so we're going to start out with, a little bit more of that.
oh yeah,
Here we go.
there we go.
All right, what is chemistry? Oh, and we need to focus a little bit. Oh, there we go. Okay. It's the science. Chemistry is a science, and it deals with the composition, structures, and properties of matter. And how that matter goes through changes. So what happens to that matter in different conditions? So if it's cold, what happens? If it's hot, what happens? Those sorts of things. So go ahead and click. Okay, so there's two different types of chemistry that we study. Organic chemistry is one of them, and inorganic chemistry is the other. So with organic chemistry, we could say that anything that contains carbon, any substance that contains carbon, and you probably heard a lot about carbon on the news when they talk about climate change, they talk about carbon footprint and all these things. But carbon comes from things that are, or once were alive. So anything that was formerly living or is living contains carbon. So that's where we get organic chemistry from. So things we use in the salon, hair colors, texturizers, shampoos, any kind of styling aid, nail products, those are all considered organic chemistry. Inorganic chemistry. So if organic chemistry is anything that contains carbon and once was alive, inorganic chemistry does not contain carbon. So it's any substance that does not contain carbon, but usually contains the element hydrogen. So a lot of times they say with organic chemistry, if you can burn it, if it's wood or paper or if it catches fire, generally it's categorized as organic chemistry. But there are some substances in inorganic chemistry, if they contain hydrogen, can burn. So that's not always a flat rule, but the carbon thing is. So when you think of inorganic chemistry, things that were never alive, like rocks, glass, air,
Water.
pure water, oxygen, hydrogen, a lot of your oxides, your zinc oxide, what's the one I'm trying to think of? Sodium hydroxide. There's a lot of stuff that we use that is also inorganic chemistry as well. So when we're talking about chemistry, we always talk about matter.
Okay, this is anything that occupies a space. It has weight. All matter has a physical, chemical properties. It exists in the form of either a solid, a liquid, or a gas. So everything exists for your matter. Then you have your elements. These are the simplest little forms of matter. It cannot be broken down into a simpler substance without losing its own identity. All matter in the universe is made up of these elements. They have their own distinct physical and chemical properties. So each element is identified by a letter symbol. O would be for oxygen, C would be for carbon, H would be for hydrogen, N would be for nitrogen, S would be for sulfur, just like when we talked about last chapter when we did the cones.
Yeah.
Cones.
Cones. Is it cones or cons?
I have no idea. Cones or
long
cons.
as you know, long as you know what it is.
So, and this is composed of a single part or a unit. So, this, you got to remember, on your test, it cannot be reduced into a simpler substance without losing its identity. So, there are 98 naturally occurring elements.
So y'all remember that periodic table that was in science class in high school? That's what we're talking about, elements. So when we talk about elements, the smallest form of an element would be an atom. It's the basic unit of matter. So if I have an atomic oxygen, that is one atom of oxygen. So an atom is just very simple, small. It has electrons, protons, neutrons, if y'all remember that from high school. Atoms cannot be divided into a simpler substance without some sort of, extreme chemical means, not something we would do in the salon. So when we talk about atoms, we never really experience single atoms in the salon. So when you start grouping atoms together, they become molecules. So if you've got two or more atoms, you've got a molecule. And there's two different types of molecules that we're concerned with. There's an elemental molecule. So if you've got one single element, like let's just say oxygen, O2. We usually use O2 as an oxygen molecule. It's two atoms of oxygen. Ozone is, if you've heard of ozone, that's usually out in the outer atmosphere. When lightning strikes, you get that ozone smell in the air. That's three atoms of oxygen clumped together to form a molecule. So that would be an elemental molecule. A compound molecule is two or more atoms of different substances that are grouped together. So when we think of water, most people know the symbol for water is H2O, right? So it is two hydrogen and one oxygen, kind of looks like Mickey Mouse there. H2O would be one element or one molecule of water. So you've got your compound molecules and your elemental molecules, which are just groups of atoms.
Okay. Now you have your different states of matter. So you have your solids. Remember, those are going to have a definite shape. They're going to have volume. They're going to have weight. You have your liquids. It also has a definite volume, but it doesn't have a definite shape. Okay? Your gases. Okay, sorry. Your gases, they do not have a definite volume or shape. But they do have a weight. So, then you have your vapors. Those are your gas-like states. Go ahead.
All I was going to say is when you're looking at these, your solid, that would be something like this whiteboard. Something that is solid. This book would be a solid. Something that has a shape, a weight, and takes up a certain amount of space. Your liquids they take up a certain amount of space, they have a weight, but their shape is by whatever container they're in. Okay, so if you've got, a McDonald's cup, the liquid in this cup is taking on the shape of the cup. So just liquids have no definite shape. With a gas, it weighs something. But a gas could be the air we breathe, so it has no definite shape. The volume, the amount of space it takes up depends on its container, whether it has a container. So if you have a can of hairspray, there are gases that are compressed into a space, and then when they're let out of that can of hairspray, they expand
And go all over the place.
and go all over the place. So gases, you just got to remember they have a specific weight, but no shape, and they don't take up any particular amount of space. It depends on how much they're confined. Okay.
Okay.
So
You have physical properties. So when you're talking about your physical and chemical properties, so those are your characteristics. They're determined without a chemical reaction. They don't involve a chemical change in the substance. Your physical changes. They also include color, how soluble they are, the odor, the density, a melting point, a boiling point, hardness, glossiness, that type of thing. Your chemical properties, they are determined with a chemical reaction. Rusting iron, wood burning, ice melting, that type of thing. So,
okay, so actually, ice melting would be a physical change. So your physical properties, you think about water. Water can be a solid if it's frozen. It can be a liquid if it's not frozen. It can be a vapor if it has boiled. So it can have lots of different physical properties, but it's still water. It didn't chemically change. So if you melt ice, it was water, it's still water, and when it steams, it's still water. So those are physical changes. It just means the state of it has changed, but its identity has not changed at all. When we talk about a chemical change, that's when it's becoming something brand new. So a chemical change is if I set a piece of paper or a piece of wood on fire, it is no longer a piece of paper, it becomes ash. So it is completely different, and that would be considered a chemical change. Rusting. If you have iron, you got an old nail outside, and it's iron, but after the oxygen and everything gets to it, it becomes rusty. So that rust is actually considered to be iron oxide. It's completely changed its form. It's something completely new and different now. So, a chemical change will make something new, will change it. Physical change, that just changes the shape or the appearance of. Okay, so one of the chemical changes we deal with a lot in the salon is called oxidation. It is a chemical reaction that combines a substance with oxygen to produce an oxide. So, such as the oxidation of melanin pigments in the hair with hydrogen peroxide and the lightning process. So with oxidation, we are adding oxygen to a substance and changing it. Okay, so
oxidation reduction. Okay, it's also, you have heard it you'll see it as redox. It is a chemical reaction that the oxidation agent is reduced. That means it lost some oxygen, and the reducing agent gained oxygen. So this would take place pretty much at the same time as it's going through. So
yeah. Like with a lot of single process hair colors, you have that oxidation reduction is all happening at the same time. You have oxidation going on where something is gaining oxygen and it's losing hydrogen. And right next to it, you have the reduction process where something is losing oxygen and gaining hydrogen. So in a lot of ways, they're just trading places.
Yep.
But it is a chemical reaction, and they're creating something new. So that oxidation reduction process happens with a lot of chemicals we use in the salon.
So then you have your oxidizing agent. So this is something that is going to release oxygen. Your hydrogen peroxide is going to be your oxidizing agent. Can be thought of as water with a little extra atom of hydrogen. So when you write it down, it's H2O2.
Yes.
So you've got, so if you have your developer and you leave the lid off of it, what's going to happen is you're going to end up, and all the oxygen's leaving, you will end up with just straight water. I wouldn't suggest drinking it, but it's not going to change. It's not going to work when you go to do your hair.
Right.
So
it's going to lose that extra oxygen molecule just sitting there.
the
And
strength.
we talk about hydrogen peroxide a lot because it is an ingredient in a lot of the products we use. Hair color, we use it as an oxidizing agent in hair color and hair lightener. It's used in permanent wave neutralizers. So it's a product that we use an awful lot. So you need to be aware of how that works. So that would be an oxidizing agent. So sometimes we use a reducing agent, which adds hydrogen to the chemical. So when we mix our tube of hair color with our hydrogen peroxide developer, we have a reducing agent and an oxidizing agent, and they work together to create that chemical change. When you have chemical reactions, there's two big ones we talk about when we do chemical reactions. And if you took chemistry in high school, you probably know a little bit about this. But there is an exothermic reaction. And that means when this chemical reaction is happening, it's releasing heat. So if I mix two chemicals into a bottle and they are reacting with each other, I can feel the bottle start to get warm.
Yep.
And there are chemicals we use in the salon that do this. So we need to know about those exothermic reactions because we don't want to burn anybody.
And if you've never felt it, so maybe you did some crafts where you would mix, was it like a plaster of Paris or concrete? It's not a concrete.
Sometimes epoxy.
Epoxy will get hot. That's an exothermic reaction. So
now combustion. It's rapid oxidation.
Fast.
So the oxygen is moving fast, and it is accompanied by heat and light. That means boom, like explosion, okay? Combustion means something burst into flames. This is not something we want to have happen in the salon.
Never.
Ever. And it could happen, but we don't want to happen in the salon. So we're going to stop there. That is part one. Keep those things in mind as you study, and we'll come back with part two.
Part two.